College Algebra. Today we're going to start lesson 4.2. This first video will get you about halfway through your notes, and then I'll make a second video to get you through the second half of your notes. We're just going to do half of a lesson a day. For this lesson, you're going to need a calculator. A scientific calculator would be fine. All right, so in lesson 4.2, we're going to be working with exponential functions. With example 1, 4 is called your base, x is the exponent. So for this first one, we're just plugging -2 in. And for this first one, I shouldn't need a calculator. If I take 4 to the -2nd, I'm going to have 1 over 4 squared. Remember, to make a negative exponent positive, you want to write the reciprocal of the expression, and that's 1/16. If I want to do 4 to the 5th, that means 4 times 4 times 4 times 4 times 4. Now that one you would very well want to put into your calculator. For your calculators, you're going to look for the caret key, or maybe a key that says x to the y, or a key that says y to the x. So we're going to evaluate, let's see here, 4 to the 5th. And that's 1024. All right, 4 to the 2/3 can also be put right into your calculator. You would hit your 4, and then if you use either of these keys, you would push that key next. And then you're going to have to use parentheses 2 divided by 3. Or you can use your caret key for caret, and then 2 divided by 3. Make sure your exponent is in parentheses. That should give you 2.5198421. And in this lesson, I was just kind of looking ahead here. They want you to round to the nearest, let's see, 1,000th, so 3 decimal places. 2.520 would take care of that. Okay, for this next one, again, it's just a calculator problem. So a little bit more than 4 squared, 19.698. All right. Moving on. We're going to work on graphing exponentials in this lesson as well. So if I want to graph 3 to the x, what I'm going to be doing is setting up an xy table. I'm going to start with 0, and 3 to the 0 is 1, 3 to the first is 3, 3 to the second is 9. If I do a -1, 3 to the -1st, let's see, is 1 over 3. Remember, to make a negative exponent positive, you're going to put it in the denominator. If I do a -2, it's going to be 1 over 3 squared, 1 over 9. Okay, so let's go ahead and graph. And there we go. Okay, the domain. We could use anything we want right here. Our graph is going to continue going to the left and to the right, so all reals. The range, though, it's starting at 0 and it's going up, so 0 to infinity. Notice it's approaching 0, so we have the parenthesis. If I see a negative in front of this function, that's going to indicate an x-axis reflection. If I have a -1 with my x in the exponent, that shifts it 1 to the right. This one has 2 movements, 2 left and 2 down. So you can transform these graphs just like you can any other function. All right, let's try 1/3 to the x. Let's try an xy table. So I always start with 0 unless there's some kind of transformation. Okay, so that would be a 1. And if I put a 1 in here, 1/3 to the first is a third. 1/3 to the second is a ninth. 1/3 to the negative first. Again, that flips it over to make the exponent positive. So that's 3, and that's going to be 9. Here's my work. Please try to do these without a calculator. I don't want to see decimal values here. All right, we're going to graph. And it's going to be coming in something like that. Probably more like that. All right, domain, all reals again. Range, also 0 to infinity. Graphing's not going to be too bad, I don't think. All right, solving exponential equations. Let me see what else we have. We have interest problems next. Okay, we'll do the interest problems tomorrow. Let's focus the rest of today on solving these equations. All right, one of the things that you need to do here is get the same base. On each side of the equation. Once you get the same base on each side of the equation, you can drop the bases using a 1-to-1 property. So I'm recognizing that 125 here is a multiple of 5. In fact, 125 is 5 to the third. Then, to get the same base, I'm going to write the reciprocal of the right side. When I flip it over, that changes the sign on my exponent. From here, since I have the same base, 5 and 5, I can drop them, and x equals -3. Okay, so on A, I had to manipulate one side of the problem. But on B, do I need to manipulate one side or both sides? Well, probably just one side again, because my common base is 3. You want to bring bases down to a common base. You don't want to raise a base up to a higher number. So I'm going to bring the 9 down to 3's. It's 3 squared. Going to take that to the x minus 3. I distribute. I'm going to drop my 3's. I'm going to solve for x. Okay, I'm going to cross that one out. We're going to get to C and D in a little bit. Let me show you a few more problems like this that would be helpful to you. Okay, so additional problems. 1/3 to the x plus 1 equals 9 to the x. All right, both 1/3 and 9 can be written with a base of 3. So I'm going to take my 1/3, flip it over, so that changes the exponent. And then 9 can be written as 3 squared. So I'll have 3 to the negative x minus 1 equals, oops, let me redo that. 3 to the 2x. Bases are the same, so drop them. and I'll get negative 1/3 for my answer. Here's another one. Okay, what would be a common base between 5 and 25? 5, okay. 5 squared to the x minus 3. Well, that's interesting. On that one, I get the same thing on both sides. So that just means x can be anything. So we're going to say all reals. Now, that doesn't happen very often, but there you go. Okay. Back to this part here. Let's finish off with letter C. And then the first video for these notes will be finished. Okay. You want to try to get rid of your exponent, and the way that you're going to do that is you're going to take your exponent and you want to raise it to its reciprocal power. I have to do that on both sides. When I do that, this product goes to 1. So I multiply exponents, and I'll have x to the first equals 243 to the 2/5. Now, you can put that in your calculator if you want. And the answer is 9. You can also solve this by hand. So if I take the 5 factors of 243, so I'm looking at the denominator, there's 5 factors. It's 3 to the 5th, and I take 2 of those 5, so 2/5 of my factors is 9. There's the way we do it by hand. You guys can use your calculator, that doesn't matter to me. Okay, 4/3. So moving on here, I want to take this one times 3/4. So I'm going to raise both bases, to the 3/4 power. You can do it by hand, or you can do it in your calculator. If you do it in your calculator, you should get 27 for your answer. If you do it by hand, 81 is 3 to the 4th. And you're looking at 3 of them, which is the 27. Okay, that's the end of the first part of your notes. Please email me your questions when you get going on your homework, because I know there's some weird ones in there, and we can maybe open up a discussion board on Canvas for this, or you guys can start emailing me questions and I'll put some out on video. Whatever we need to do to help you get through it, it'll happen. Have a good day, you guys. I miss you. Bye-bye.